How's it going, folks? So my buddy dropped off his drum sander and it needs repaired. It has a nut right here where this elevation screw goes into, and that nut is stripped out because it's aluminum. The design on this is they have this aluminum top here, and they have a part here that protrudes out underneath this elevation screw. They've drilled and tapped it, and that's how they raise and lower the drum sander. What the issue is, though, is a pretty thin piece of aluminum. It's maybe 3/8 of an inch thick, just not enough material there to support the weight of it. So it's been stripping out. This is a pretty common issue with these sanders. I did some research online, and the fix that people found is they'll make an insert holder. So they'll take a chunk of aluminum, drill some holes into where it mounts up to these holes in the back here, cut this tab off, bolt this new insert holder up, and then they'll take either a piece of cast iron, brass, or regular steel and make a insert that this screw will go into. Nice thing about an insert is if it fails, you can put another one in there. So that's what we're going to try to do here. I think I have enough scrap metal laying around that we can make this thing functional again. So let's get to it. Okay, I popped the cover off the back here, and this exposes the lifting mechanism. As you can see, you have your two uprights, one square, one round. Those just support this main beam up here. And they're just attached to two little grub screws in the back. So I've loosened those. We can pop this off. And then we're going to remove our elevation screw. You can see what was left of the threads is kind of permanently, well, not permanently, but it's into the threads there. That's all the chewed up aluminum. If we look inside here, you can see there's no more threads there. So the idea is to cut this off and make or use these two screws here to mount the insert holder. The insert holder is just a chunk of aluminum that will be able to take a threaded nut essentially that will sit inside the aluminum, put a grub screw in there so it's not going to go anywhere, and that's what the threads for the lead screw are going to tie into. So flip you guys around over here. So tentatively right now, this is what I'm planning on making this out of. I had some aluminum laying around, so I'll throw this in the mill, shape it up into the type of part we want, and then I have this brass here. I'm thinking I will use this as the insert that will sit inside here that the elevation screw will go into. This elevation screw is a 9/16 by 18, and that's the closest one I could find that'll fit this. It's a little bit, it might be a little bit bigger, so I might have to, so by bigger what I mean is that nut that I'm going to make here is going to be a little sloppy on this nut, or on a screw, so I might have to run a slit down it and then make it basically a compression nut. So hopefully that'll make sense when I actually start building it. I'm going to try test fitting it out and seeing how it fits before I need to make any more modifications on it. Okay, we're over at the lathe now. I got my insert part that I'm going to be making chucked up here. I'm going to make this 1.5 inches deep. I'm going to drill it out with a 1/2 inch drill bit, and then I'm going to bore it out, and I'm going to tap it and then part it off. And this is going to be my insert. So I should go to the place here. So, screwed up, and the old adage, measure twice, cut once. Well, I never measured, I just went off the schematics that I found online, and those were for a different drum sander. So the holes are set too close together and they do not match up with the ones in this. Since I cut this at an angle, I don't have enough stock to move the holes over and re-drill them. So I have to build another one of these. I'm going to try instead here, since I was going to cut this off anyway, just to see if it'll work. I'm going to see if I can bore this out, and then that insert, that threaded insert, I'm going to see if I can put it in here and then drill in and tap threads for a set screw to see if I can make that work and then keep this original piece here. We'll see how much I have to bore off, and if it looks like it will, as you remove material, obviously it should become weaker. But if I can have enough material in there and get that insert in there, and it will still lift up and down, then that will negate the need for cutting this off and putting in this block here. So we're going to try that, and I'm going to start boring this out, and we'll see what it looks like if I can get that insert to fit in here. Okay, so this is where we are with the build. This is the top plate of the drum sander, and the original idea was to cut this tab off, and this block that I had made here with these two holes drilled into it, it was going to mount into this using these holes that are in the factory casting. Well, since I did not measure this or measure this piece right here, I just went off a schematic I found online. These holes don't line up. I don't know if that shows up in the camera, but these holes are too far into the center. And since I cut off this material at an angle, I don't have enough material to re-drill holes in here. So this essentially is a piece of scrap metal at this point. But I got to looking at this, and so I took this over the mill. I bored it out to 0.672 of a thousandths, and then I took the insert here, I threw it on a lathe and took this down to 677. So that's a 5/1000th of an inch difference. That should be enough to get a nice press fit in there. Actually, it'll come up from the bottom side. Pardon me, I'm doing this wrong. So it'll come up from the bottom side like that, because all the force is gravity going down. The most of this force that this machine is going to be experiencing is being lifted up. It'll naturally want to settle back down. So by having the shoulder on here, the shoulder will catch on the bottom part here, and that will hopefully be enough material left in here to lift this up and down and hopefully give us years of service out of it. So I'm gonna go ahead and freeze. I go ahead and freeze this part here so it will shrink down. I'm gonna heat this part up. I'm gonna take it over to the arbor press, and I'm gonna press this in. So I'm over here at the arbor press, and I'm just going to add just a little amount of heat. Try not to even melt the paint here. And what I'm trying to do is just get this metal to expand. So when I go and pick that insert out of the freezer, this will be hot, that'll be cold. Obviously metal expands when it gets hot, and metal shrinks when it gets cold. So that'll make it easier to press this in. And then when they come down to the room temperature, they will hopefully be a nice press fit, will not come loose. We will be in business. All right. It's perfect. Let's reassemble this and see how this works. Okay, so here shows the fix of what we did. So you have this insert right here that is coming out from the bottom. So it obviously has a flange right here, so that's going to support all the weight of this as it lifts it up and down. Gravity's going to pull it back down, so I didn't feel the need to put a grub screw in here. And it was a pretty tight press fit when I went to push it in with the arbor press, so hopefully this will stay in here. If not, you know, I can put a grub screw in here to keep it from spinning, but I don't think we're going to have any issues with it. I didn't use any Loctite or anything. This is just a pure friction fit in at this point right now. So next thing I'm going to do is I'm going to put on the top assembly here, and I'm going to do some tests with it, see how it runs up and down. It appears somebody put grease on this at one point, these two arms here, to assist this to go up and down. That's probably not the greatest with a drum sander, because drum sanders make this really fine dust, and it gets in everything. It's insidious. Even if you're running dust collection on these, if you have grease on anything, the dust will find it. There's no way around it. So I may have to clean this up. I'm going to look on the instruction manual and see if this is normal for it, but I can't imagine greasing up exposed pieces of metal like this is a normal procedure for something that gets this much dust. Alright, we're all done with the repair job on this. One thing that I was not able to capture on video because my camera died was this top knob here for this hand wheel, just so you can grab it and spin it a little bit easier. All it is a piece of metal that I knurled and then put a bolt through. So it works pretty good there. As far as the insert that I built, I'm really happy with how it came out. I think it will do just fine in there, and it's just a different way of repairing these. I was going down the one track of building a insert holder, cutting that tab off, and ended up screwing up the part, and so had to adjust and was able just to make the insert fit in the existing hole. So just a different way of fixing these. If you're have something like this that you're looking to fix, maybe this might be give you some inspiration or be an option for you. One thing to note that I didn't address it quite right is the measure twice, cut once. When I looked at the schematics, I did grab my calipers and I did measure the two holes here. Where my screw up happened was when I was using my calipers to measure and mark out these holes here. What I noticed afterwards when I was going back and trying to figure out what happened is this is a cheap set of digital calipers and it's jumping numbers. So what that means is it's not accurate. It would jump a quarter of an inch to half an inch difference. And I think that I'm right on because I'm going off the numbers here, when in reality I should have double checked it physically to the other holes here to make sure the two line up. So just some food for thought for you. Unfortunately, cheaper tools, it's what a lot of us start out with, and it's all we can afford, but you have to triple and quadruple check your work with it too, because I'm having issues with it now because I got somewhere in there's some grime or something that is keeping that reader from reading properly where it's at. So just a learning experience for me. I'm gonna be a lot better about double checking my work before I start drilling, and until I can afford an extra set of calipers. So just something to think about. Anyway, hopefully you guys got something out of this video, and thanks for checking it out. Have a great day.